couple of months ago, I picked up a treadmill. You know, I've always watched YouTube videos where they reuse the treadmill motor. And so I decided that, well, I'm going to pick that thing up. It was free. It was on the side of the road in front of this guy's house. He was moving, and I thought it was a garage sale. So I walked up there, and he said, nope, but he didn't want the treadmill. So I picked that up. It was free. So anyway, I took the motor out and actually found a lathe that I could put it in, and I put it in a lathe. So let me show you the video about it, talking about it. The parts, in the video, I talk about the parts for the actual to make the treadmill work on a lathe, being like $250. Well, it's not. It's like $160. The rest of it was a tap and a bit and a die to make the little adapter with. But so let me go ahead and start this video and see if we can see if I can show it to you. I had fun doing it though. Let's see. Now, can you see it?
That's great. Yeah.
There you go.
All right. Let me start it again.
Talk a little bit about a lathe motor conversion. A friend of mine has a lathe that had a bad motor in it, and I found a treadmill motor. They were throwing them, they were moving, and they could throw them kind of away. They didn't use it anymore. Perfectly good treadmill. Still had the receipt with it. The game was 10 years old, but it was like $500 for Sears. So anyway, I took it all apart and pulled it apart and pulled the treadmill motor out of it. I actually kept the controller for a while until I realized I didn't need it. I got on YouTube and was looking around, and I found Dave's Cars, D-A-Z-E-C-A-R-S. And he has a lot of videos using treadmill motors. Very good explanation of it, how it works, what you need, how much everything costs. So anyway, so I took that motor and threw the controller away, the board that actually controlled everything on the existing treadmill, threw that away, and I bought the parts that he suggested. There were like 6 or 7 pieces that you have to buy. I think the whole thing runs about maybe $230 or something like that, maybe $250. But anyway, it was a doable deal. The friend of mine that had the lathe, was willing to pay for the conversion. So anyway, so I enjoyed the experience. Let me show you this motor. It was it's a 2-horse, 2.65 horse motor. So as you can see, the motor itself, as it says, it's a 2.65 horse. But when you really get down here and look, it says it's a 1.5 horse continuous duty, 95 volts DC. So it's a DC motor that has lots of torque. This thing has once it gets up to full speed, which is real fast. But anyway, it gets up to full speed. It's like 4,000, maybe 5,000 RPM. So it has plenty of speed, plenty of torque, and it's just putting all the components together. And like I said before, it's like 6 or 7 components. I didn't video it, but that I can give you a description of it. But the best thing is just to go watch his videos. It's Daz Cars videos, and he actually has a webpage. If you go to dazcars.com, he has some of that stuff out there on his webpage. But this is an easy conversion. You just have to find a way to mount the motor. I kept the bracket out of the motor. As you can see, I've cut it off and kept that bracket so I can use the adjustment portion of it. And we're going to put it in the deal. There's only 4 wires coming out of here, but 2 of these wires are thermal protection in the motor. So if the motor gets too hot, it opens up. and the other two are the DC, the plus and minus to the DC. These are reversible, you know, and that's what we're going to do. We're going to reverse the motor and run it in the opposite direction and let the brushes burn in. You know, it's probably not a good idea to switch it back and forth. You could. It just makes the brushes wear out faster. But anyway, we chose not to do it because I don't want to have to go find another motor somewhere or try to find brushes for it. So hopefully this thing will work great. All right, I've completed the lathe conversion and also made a stand for it. I'll show you the stand in a minute. This was a 1016 Laguna, and I have raised it. You know, the motor's strong enough, so I went ahead and raised this thing up to make it a 1216 with spacers under both ends, headstock and the tailstock. And then I had to drill out the banjo. The banjo was, I don't know, like a ½ inch or something, probably maybe 5/8. Anyway, I drilled it out to 3/4. I thought that was too small for what he's doing. Then I made some adapters here, tool rest for his deal. I've got a 6-inch, then I have a 10-inch, and then I also have a platform that goes on here. But the conversion itself turned out good. I kept the existing box that he had here that came with it, kept the switch, the tachometer that was in here. It probably didn't work. None of that electronics really worked, so I took it away, threw it away. I bought a new one. This is 110.
We lost audio.
The audio back on again. Okay. And then we'll try this again here. Let me share the screen. And hit play.
Suggested.
Now can you hear it?
And it worked out fine. I don't know that I need the second one. It was like a coarse adjustment and a fine adjustment. I don't know that I need that. So I took everything off the shaft on the inside of this thing. Took the pulley off. You reused the same pulley, but took everything else out of here. Put a different sensor inside, and that one works off of a magnet. So I had to glue a magnet to the shaft to make the tack work. But I did have to make an adapter. I had another friend who had a metal lathe, and he made this little adapter, video, Bob. 3 or 4 inches long, maybe a little longer.
Do what?
We lost your video.
Yeah, I still see it.
We got it.
I have it.
I still see it.
Okay, then
it screws on where this hand wheel used to screw on the end of the headstock shaft here. So the adapter, screws on here. I could reuse the pulley. He put that on here, and then we threaded this end to put the hand wheel back on. Didn't have to have it, but I thought it was an added feature that he could keep his hand wheel. It is hollow. We went ahead and drilled it out so we can still use a punch out or a knockout or whatever you call it, and he can still use the mortise taper on the headstock. The bottom down here, this is a brace I made. I probably didn't have to be that thick, but I made it good and thick where it's not going to move. And I tried it at first on this center pulley, and it would have worked fine, except the lowest it would go, the lowest speed was about 450, and the highest speed was over 4,000. So I said, well, we don't have to have that. So we put it on the larger pulley, went ahead and put it up here, and still running it on the existing portion on the on the motor. But then when we put it up here, that dropped the speed down to 350 and a little low, probably 36,000 or 3,600 RPM. So it's plenty fast. He's never going to go that fast anyway. Well, anyway, let me finish showing you this. You know, I used the bracket. We used the bracket that came with it. Just cut it off, and you can see, but I did keep the adjustment portion where you can adjust it and change the belt out. All electronics fits in this box. Well, it's actually two things. One thing is in the box. That's that SCR controller. It has a little fan in it. I left some space in here to let the heat out. I'll put it on spacers. This is a rectifier. It's a bridge rectifier. Because the SCR controller converts the AC into kind of like a chopped AC, and you still have to make it DC. So you put it through the rectifier to make it DC. And then on the back of this board, which I've got still shut here, I've screwed it shut. But on the back of that is a transformer. Not a transformer. It's a choke, basically what it is. It's it looks like a transformer, but it's really a choke that kind of smooths out the DC before it gets to the motor. And that's it. You know, there's not a whole lot of parts. There's a fuse. I had to buy a circuit breaker, and but the rest of it was all came with it. I mean, you know, it was, like I said, 5 or 6 parts. Pretty easy to do. The conversion's easy to do. There is the speed sensor, and I don't know if I can turn it here to where you can see I don't know if you can see that or not. There he goes right there. Where I had glued the magnet to it. I went ahead and made a stand. He didn't have a stand either, so I made a stand out of 2x2 square tubing, 16 gauge. Put it on wheels, 4 or 3 casters, and have jacks under it where you can lift it up, and lower it. So you can lift it up on the casters and move it around, and then set it back down again. And being 11 gauge, that the stand itself is probably about 160 pounds. And then when you add the Laguna lathe, I don't know how much that thing is, maybe 50 pounds or something. I don't know what it weighs. So it's probably close to 200 altogether, maybe a little more. So if you wanted to, you know, the bottom has got the shelf looking thing down here, the braces. You know, he could stack sandbags or something on it, but I don't know if he's going to need it. If he doesn't get too high or get too big a rough piece on here, I think it'll be fine. I also made a little attachment where he can put his light. The attachment sits on this, wraps around this square tubing, and it sticks out the back, and it'll slide back and forth on the tubing, and a deal sticking up so we can put a, you know, like a LED light, move it around back there. So anyway, it turned out pretty good. I think it's going to work fine for him. What else can I say? The metal for the stand was probably about $250. The price of metal's really gone up. But that's it. Let me turn it on for you so you can see it. It'll actually stop if I turn it all the way down here. It will stop, and you can turn it up. That'll finally zero out once it settles down. But so about 350 is about where he's going to start, and I can't hardly reach this thing, but it will go way on up here. All the noise you hear is the fan. There's a fan in that motor. When it says 3,200, but I can get it higher. Here you go, let's play the 800. So there is some adjustment in the smaller deal. But like I said, all of the noise you hear there is really just a fan turning. You know, I could put that all in a box and you wouldn't hear the fan so much, but I don't think it's going to hurt him. Anyway, if that becomes a problem, we'll put a deal on it. That was why we didn't want to put the motor underneath this lathe like it normally comes, because the fan would just suck sawdust right through it, and it would just clog it up. So, you know, we thought it would be better over here to make the motor last a little longer, sticking it off to the side. And I think it worked fine. I don't think it's going to be a problem. Anyway, I think that's it. Have any questions, just let me know.
That's pretty good, Bob.
Yeah, thanks. It did work out real well. I don't think he's had any problem with it. It has 1.5 horse now instead of, I think even a 12-inch Laguna lathe is only like 1 horse. So I'm not real sure, but I think that's what they are. And, so this is 1.5 horse. It has plenty of torque. You're never going to stop it. It's really, really a good motor in there. But talking about motors, you know, if you don't have a treadmill, I think you can buy these motors on eBay for like $70, $80. So, you know, they're not that expensive to buy that DC motor. Some of these you can't buy. You know, like if you go out and you're trying to replace a motor in an old lathe, they don't sell you a direct replacement because that part you can't buy anymore. You'd have to find something that's going to fit. So this is, to me, was a good alternative.
I think genius.
But it worked out real well.
The motor said 21.4 amps. Is that right?
No, it was a 2.45 or 2.46 horse motor.
The amperage on the label, I thought so.
Oh, well, I don't know. I don't know what the actual amperage is. I wasn't looking at that, but you really don't need to worry about that amperage in it. It's a DC deal, so you know you're not. You know, if you wire it up correctly, you're not going to have a problem.
Nice job. Nice stand too.
Yeah, thanks. Absolutely. The stand worked out real well too.
Yeah.
Good info, Bob. You can take your toolbox to a Goodwill store and take $20 with you, and somebody with a strong back, and usually make a pretty good deal.
Yeah, that's right. That's right. They are those treadmills are heavy. I'm telling you.
Mm-hmm.
Yeah, Bob.
Yeah.
This is Randy. One kind of a caveat is that you can reverse the rotation of that motor and hence the lathe just by reversing the 2 leads that come out, switch positive and negative, and you can use a double pull, double throw switch.
Yeah,
and you'll find all kinds of descriptions of that on the internet.
Yeah, you can, and he even says that on his website. I just when you do that, it's the way the brushes work. You know, brushes in a DC motor, any type of brushes that are going the same direction all the time, they get burnt in that direction. And there's enough slop in the actual channel that brush sits in to where you turn it back the other way. Well, it slaps it up against the other side, and now he's turning that direction until it gets cut in. So yeah, you can. I mean, and we could have done it here. And in Dad's cars, he actually does it. He's got that on several different applications, a lathe and a mill. Anyway, several things, and he did reverse that motor. I just opted not to do it.
Yes, absolutely. But here's the caveat. You cannot do that. You cannot reverse the direction of the lathe while it is spinning.
And no, you're going to burn it up. Yeah.
Absolutely. You'll burn up that controller.
Yeah.
Wait a minute. They told me at Jet you could, or at Powermatic that you could do it, and I do it every day.
Well, that's a different
Yes,
application, different setup though.
Okay,
that that is a variable frequency drive, not a variable DC drive.
Yeah.
okay. Yeah.
You
I hope-
post that website?
Daz Cars, DAZECARS.com, or just go to YouTube and look up Daz Cars.
Okay.
And,
Bob, can you put
you'll
that in
see
the
all
chat?
of it. Sure, I'll
Folks that are interested in it.
Sure. But I thought it was a good alternative to trying to find a motor for it. You know, several of the guys around here had already told him just to throw it away because it wasn't any good, and he hung on to it. And anyway, we ended up putting a motor in it, and it worked great.
Yeah, I would say so.
Nice save.
Yeah.
Great job, Bob.
Okay.
Very intuitive.
Thanks.